But hello, ladies and germs. Hope you guys are doing well today. Happy Thursday. So yesterday we had a quiz. I should have this graded by tonight, and they should be in RenWeb, as well as your homework for the week should be graded by tonight. Tomorrow's my, or I guess for me it's tomorrow. For you it's today. Is my catch-up day. So we talked about common logs, right? A log was a way to see what number do I need to raise this to the power of to get this number, right? What power does 10 need to be to give me 100? The answer would be 2, so the logarithm is 2. It's a way of getting somewhere. Now we come into the fun world of natural logs. So these are different than common logs, and their purpose is different as well. So let's just jump right into it. So first, let's get a definition down for what this is and what this is. What is ln of x and what is e of x? So ln stands for a long Latin word. Let me see if I can find it on my page real quick. There's no reason to have this, but it's fun. Um, Logarithmus naturale. Logarithmus naturale. That's a fact to share at the dinner table. Really boring, but this is just literally called a natural log. This is not a natural log. This is an e, and we'll get into what e is tomorrow. But today we're going to be talking mainly about the natural logs. But let's get some definitions down. ln of x is going to be a tool we use to tell the time needed to grow to x. The time needed to grow to x. Okay? Now before you ask, Mr. Brown, what the heck does that mean? So let me give you an example. Let's say I put my money in the bank, and let's say I put $100 in the bank, and I want to say, how long is it going to take for that $100 to turn into $110? A natural log is how you find that. How much time you need to grow to a certain number, and that's what this number is. So this solves for time. What does E do? E is the, oh wow, that's a R, by the way. Growth, that's an ugly R, wow. Growth after time, which is X. So these are kind of flipped. So the natural log is saying, how much time do I need to get to X? E of X is saying, how much do I need to grow to get to time? So one helps you find the growth, the other one helps you find the time. So let's see where this takes us next. So starting off, E is about growth. Okay? That's cut and dry. If you end up reading about a problem that asks you about E, or it asks you about growth, you can know for sure that you're going to be using e to the x power. So what e really means, e to the x is, I hope that's clear enough. That looks better. How much growth do I get after x units of time? How much growth do I get after x units of time? Let's say I'm talking about years, and I'll talk to you while you're writing this down. How much would my bank account of $100 grow after 2 years? How much should it grow after 5 years? How much should it grow after 15 years? That's going to change based on what I plug in for my x. So let's say this is 5 years. I'd say e to the 5 should tell me how much growth I get. For example, after so many years, I got to fill this in so you're not hopelessly confused. Let's fill this in. So, for example, after 3 years, okay? After 3 years, I have e to the 3 times the amount of stuff I started with. After 3 years, I have e to the 3 times the amount of stuff I have started with. Now, how do I figure out what that is? Let's turn my brightness up so you can see this. Okay, so looking at my calculator, I have an E button. I don't know if you do. I hope you do. Let me focus this in. How do I get this to focus? Just take my word for it. This is an E. E. Notice it has a number here, 2.718. We'll get into that tomorrow. But e to the 3 should give me a number. So e raised to the third power gives me this number, 20.08. Roughly 20.08, 20.09. I'm going to write 20.08. I mean 9. So after 3 years, I have e to the 3, or 20.09 times the amount of stuff that I started with. Well, that's helpful. So, let's explain this a little more. So, pretend that e to the 3 isn't there. That's how we get this number, but this is the kind of question this problem will let us answer. After how many years you would have blank times the amount of stuff you started with? If I start with $100 and I now have $200, that's 2 times the amount of stuff I started with. How many years would that take? That's what EX helps you with. Now let's do a little bit about ln. While E is about growth, ln, natural log, is about time. E helps you find growth, the natural log will help you find time. In other words, if e to the x lets us plug in time and get growth, and stop writing for a second and listen to this sentence real quick. If e lets us plug in time and get growth, then the natural log lets us plug in growth and get time. And get the time it would take. Oh, just barely. If e lets us plug in time and get growth, the natural log lets us plug in growth and get the time it would take. Pause the video real quick if you need to finish writing that, and then I will continue to the next page. So, for example, and this is on that natural log, I just ran out of room on my page. For example, on the natural log, e to the 3 equals 20.08. What this means is, after 3 years, we have 20.08 times the amount of stuff. We already said that. But what is ln telling us? This means if you put ln to the 20.08 or 20.09, watch this. If I push the ln button, which for me is right here, and I type in ln and then 20.09, I get 3.0002. So if ln 20.08 equals 3.000 dot dot dot, I'm just going to round that to 3. If my natural log of 20.08 equals 3, this is saying if we want growth of 20.08 times the size, we have to wait 3 years. So here we plug in the growth rate and we get the time. So for e, we plug in the growth. For e, we plug in the time and get the growth rate. For natural log, we plug in the growth rate and we can get the time back. Now, an important point, and hint, hint, this is going to be a thingy on your next quiz. This is all assuming something. This is all assuming a 100% continuous growth rate. Sort of like in science, we have things at STP, at standard time, that you can kind of predict. You can't really predict how quickly money is going to grow normally because everyone has a slightly different rate in a slightly different time. This kind of math we're going to be doing is assuming that over a period of time, your money will increase by 100% over and over and over again without the rate changing. Now, the rates in America are based on the economy. So sometimes you'll get a rate that'll start off low and then it'll get jacked up really high because something happens. Or you'll have a really high rate that drops down low. We're assuming that it's going to continue at the same speed forever, 100% over periods of time. Okay? So let's do some examples. All right. So for ln of x, what are we looking for? For our natural log, what are we looking for? Let's look at our notes. ln, we're looking for time. Plug in the growth and get the time. So for ln, we're looking for time. So what would ln of 1 be? Well, let's plug it in, plug it in. Please get used to plugging this in, or find a way to plug it in. ln of 1 is 0. Why is it 0? Well, let's think about how these problems make sense. If the growth rate, how quick, if I'm increasing by 20.08 times, it's going to take 3 years. If I'm increasing by 1 times, how long does it take for something to increase by 1 time? Well, if you put in $100, what's 1 times $100? $100. How much time did that take? Nothing, you already had it. So if you have a 1 in there, this is saying it takes no time to increase by 1 times growth rate, or by 1 times growth. All right. Number 2, that's homework for you. I want you to plug this into your calculator and explain to me why that answer makes sense. If you need help explaining that, look back at this problem. Example number 3. I want to grow my bacterium, my collection of bacteria, at 15 times the size. I want to make it 15 times bigger. How long do I have to wait? Well, what am I looking for? How long? I'm looking for time. Which equation helps me with time? Natural log. So let's use my natural log. The natural log of my growth, what's my growth rate? 15. This should give me my time. So let's plug it in, plug it in. Natural log of 15. Oop. Looks like that gives me 2.71. 2.71 somethings. I didn't tell you if you're going to use years or minutes, so you can't really answer that. I should have. That was my mistake. Oops. I'll give you a rate. In fact, I do give you a rate because in example 4, I ask you a similar problem and I ask you for how many months it will take. That will be up for you. Last thing, I've got 2 questions for you. Number 1, what happens when you take the natural log of a negative number? Try it in your calculator and see what happens. And then explain to me why it doesn't make sense. And when you're asking yourself that, if you're having a hard time answering that question, try to put it in a word problem. And if you can't put it in a word problem, sort of like this one, explain why it doesn't make sense as a sentence. The last thing I want you to do is to list 3 things that grow in a way that you'd use natural logs in the real world. So I used bacteria and I used money. Find 3 other things that you could grow and should grow over time like that. And I said hint Google, because Google is your friend. Looks like that's it for me, folks. I hope this lesson made sense. Again, I'll have your quizzes graded by tonight. They should be on RunWeb. And yeah, hope you guys enjoy natural logs. This is one of my favorite things to talk about in math. They're just kind of cool and fun. And unlike a lot of math, it's actually helpful in the real world, which is always good. Anything that has to do with money is fun. So, hope you guys have a good rest of your day. Good luck on the homework. Let me know if you need help. Bye.